rate of convergence. The rate of convergence. Would like to comment this. Although we should keep this link for the computational procedure. When we talk about the computational method, then a rate of convergence is very important topic to study the computational rate. We are going to discuss the point I was to. And so you can say that wherever we have the computational procedures or computational methods involved somewhere. When we have computational methods involved somewhere in the process of mathematical methods, then we study separately and analyze separately the rate of convergence. Since the numerical methods implies very, very seriously all the methods of computations, and therefore the first very unit or first very chapter even discusses the application of the rate of convergence or study of the rate of convergence. Rate of convergence through what? Now there are two prominent ways of studying the convergence. These prominent is what? The first one is the linear, and second is the non-linear. To study, when we make endeavor to study the convergence, linear convergence, then we take the help of the sequence. Sequence is the simplest way of studying the linear convergence. Now then, what is sequence? This is very interesting topic of the applied real analysis. It comes in the where? Applied real analysis. In the applied real analysis, because without the knowledge of the sequence and series, why this is applied? Because this is a common area of the pure as well as the applied branches of the mathematics, as well as the other branches of the science and engineering. So without sequence and series, we cannot study the other branches of the mathematics and science engineering, and therefore this is a part of the applied real analysis. So, but here you must be studying as a part of the real analysis. Sequence. What is the sequence? Sequence is nothing else. So when you talk about the domain and talk about the image set or the range, then here, if you take the first, you take the literal meaning of sequence. Literal meaning of sequence is what? Put the things in order. Put the objects in order. Okay, so when we put the things, literal meaning, put the things in order, this is a sequence. When things are systematic, or you can say when things are systematic. Systematic means either things are in order or in system, that is called a sequence. So order and system is explained by what? Put our things in order, or put things or objects are put in system. What does it mean? For this, we have very good manner of the natural numbers. Natural numbers. Natural numbers, or this is known as a computing number. Computing number that tells us the order of the objects or the order of the things. What can only tell us? Natural in the sense is what? Natural in the sense that 1, 2, 3, 4 in this order. Put the things like 1, then 2, then 3, then 4, so forth. So on. This is the order. Means if in the rooms, the first book, second book, third book, fourth book, you arrange. So first book would be what? If you are going to file the books, if you are going to file the books, file the books, file the books. File the books means keep the books in order. File the books. What you will do? Book number 1. Book number 1. Book number 1. What will be book number 1? Which one is? Which one is biggest book? Okay. So book number 1, which will be on the bottom, is the biggest book. Thereafter, the smaller. Thereafter, the smaller. Thereafter, is smaller, and the smallest book will be on the top. This will be arrangement in our room. So order is what? 1, 2, 3, 4. But 1 is well defined, 2 is well defined, 3 is signifying the good value, 4 is signifying the good value. And if books are of the same size, then there is no problem. 1, 2, 3, 4, just keep on piling the books. So literal meaning of the books that we are going to use the natural numbers, natural order. When we talk about the natural number, this gives us the natural order. Natural order. Natural order is defined by the natural number. And therefore, the literal meaning, when comes in the light of the mathematical concept, the sequence is defined by what? What is the definition of the sequence? Do you remember or not? Sequence is a function whose domain is a set of natural number. So sequence is a function. This is a function. This is a function whose domain is, always you can put here. This is a universal truth. We cannot, any mathematician, any scientist, any common man cannot change this definition. This is a function whose domain is always a set of natural number. Set of natural number. Always a set of natural number. Always a set of natural number. Now things are very clear. Therefore, we talk about the natural numbers, but whenever we talk about the elements of the sequence, elements of the sequence, elements of the sequence of the sequence is what? Elements of the sequence is what? Element of the sequence is A. This is the first sequence. A, it is, you put the order. A is what? A is 1. Therefore, suffix is always 1. And second element is A2. Third element is A3. So 1 is very important, 2 is very important, 3 is very important, element 1, element 2, element 3. And if you say I'm going and so forth, so on. This is how many numbers? How many numbers? Set of natural numbers. In so forth, so on. The infinite number of elements will be here. Because domain is a set of natural numbers means infinite. How many natural numbers? Infinite number of natural numbers. Infinity itself is not countable, but each and every element of the natural set of natural number is a countable set. And therefore, the set of natural number is a countable set. And if you say this is A3, this is A3, I take A2, then I take A3, then I take A1, then I take A1, and then I take A5, I take A5, so forth, so on. Then is it A5? This is not A5, so forth, so on. Is it a sequence? Is it a sequence? No.
No, sir.
This is not a sequence. This is not a sequence because this is not a definition according to the laid down or underlined laid down definition by the mathematics. The natural number are written in the natural way and therefore always put it A1, A2, A3, so forth. This is not in the order. Things are not in the order. So this is very important. This is a sequence. I revised your knowledge of the sequence. Set of natural number whose domain is a set of natural number, and function is what? Function is a relation which maps each and every element of the domain to some exact or unique element of the codomain or the range that is known as a function. But sometimes one element of the each element is mapped to two elements, that is not a function as per definition of the function. Then that comes the case of the multi-valued function. For example, when you take the 4 in the domain, you will find the two elements in the codomain, that is -2 and +2. Then how the single element is going to be mapped by two elements, that becomes the case of the multi-valued function. So there are several cases of interesting cases of function. So function is what? Function is a machine, I told you once upon a time while we were taking the classes in the computing science or computing fundamentals. This is just like a machine which has an input, which has an output, and the in between whatever the throughput is. So input is the elements from the domain. What is the output? The elements of the image set or the range. And throughput, three terms I had discussed, if you remember, during or while making the classes in the computing fundamentals. The throughput was different. So input, the point is the input, and second was output, and the third was in between input and output there is an another process, that is the throughput. So throughput throughput is what? Here throughput is a function. Throughput is a function. Throughput is nothing else but this is a function. This is a function. This is going to study the sequence for the linear convergence. So convergence will be two types. One is the one is the case of linear and another is case of nonlinear. So linear will be studied through the sequence, and I told you sequence. I I just discussed, revisited the definition of the sequence, as well as I revisited the uh, concept of the function. And then in the function, what happens? If you remember, in the function, domain is there, codomain is there. In the domain, each and every element of the domain. We always talk about the each and every element of the domain. Why we talk about the each and why the each and every element is important in the domain? This definition is made, is defined universally by the mathematicians, but why I had given you this also, if you remember, the as a mind boggling exercise. Always apply the mind's creative something new, and the answer to the why, answer to the question why must be sought, must be explored by us in a positive manner, not in a negative manner. Always don't say why I say you have to do this work, you have to perform this action duty. You say why I should perform. Your father says something, you say why we should do this. No, no, no. But why in mathematics is very important. As I raised a question before you that why each and every element, why each element of the domain is mapped to some element of the codomain in the definition. So look at the definition from the innovative point of view, from the creative point of view, why the conditions, why the preconditions have been made sometimes, somewhere in the definition. Anyway, this is a question for your homework. A sequence may converge to a limit. Now, this is the total is the real analysis. The limit, you must know the difference between the limit. You must know the difference between limit and limiting points. Limiting points may be number of limiting points, but limit is always unique. So unless you get the unique limit, the function, the sequence may not converge, will not converge. And therefore, this makes the difference between the limit and the limiting points. This is very interesting. Why we take the limits of the sequence or function? What is purpose of studying the limit of function? Why we take the limit? Limiting case. Why we study the limit? What is need of studying the limit? This is another homework for you. So linear fashion or in a non-linear fashion. Here, one statement I am just underlying this point for you, that a sequence may converge to a limit in a linear fashion or in non-linear fashion. If the sequence is convergent, then an iterative operation produces a sequence of better and better approximate solution. Then an iterative operation produces a sequence of, this is very important. I prefer the color pink. A sequence of, you just uh, note this very point is important. A sequence of better and better approximate solutions means you are choosing, the most suitable approximate solution, and most suitable approximate solution out of a sequence, the solution number one, it has come out of the first iteration. The solution number two, it has come out of the second iteration. Solution number three, it has come out of the third iteration. So this is a sequence of solutions, and naturally, all the solutions are approximate solutions. And therefore, the last one, the last A1, A2, A3, A4, A5, A6, so forth, so on, up to AN. And N is what? N keeps on keeps on increasing. That may be a very large quantity. But the approximate solutions are not to have the infinite number of times or very large number of times of iteration process. One iteration, two iterations, three iterations, 4, 5, 6, 1, 10 iterations, 100 iterations, 1000 iterations. Can you make the 1000 iteration? We cannot make it manually. And therefore, computer is here. But computer has also limitations. Computer has also limitation of its computing time. Computer has also limitations of the memory variables. Computer has also the limitations of the time complexity. So we can say this sequence of better and better approximate solutions will be generated, and that the approximate solution, which will be the closest to the true solution, true value, that will be our final result. Now, linear convergence, I just now linear convergence here we consider a sequence, no doubt, x1 x naught x1 xn. This is a sequence. Okay, so similarly, A1, A2, An, here it is Xn, and these are the arguments, and generated by the iteration. This is the iteration process. This is the iteration process. This is your return. X naught, X1. This is the this is a iteration process. So if k is equal to 0, then what will happen? K is equal to 0. Then it is x1, x1. K is equal to 1. Then this will be x2. So you are getting x1, x2, and here the function of x, that is a solution, x is equal to k is equal to 0, means x is equal to 0. So you are going to start your iteration process with k is equal to 0, then x here becomes, k becomes 0. So this becomes g and x naught, and this is equal to x1 is equal to this. This is the iteration procedure. This is the iteration method is going to produce like this. This is not any particular method, but this is the general way of expressing and representing the iteration procedure. So we have started from x naught. So this value is what? X1 is here. You are getting x1 is here. Then how you get x naught? X naught is what? X naught is a initial guess. You remember or not? Initial guess. Initial guess. Without this initial value, the computation will not start. Iteration process will not start. So this is the x naught. This is the x naught initial guess. So we start with the initial guess, then x1, then x, so forth, so on up to x, and generated by this iteration method. Table 1.8 list k, value of k, xk, delta x. Delta xk is what? Delta xk. Delta xk, this is the difference. This is the error. This gives the concept of the error in the measurement, in the computation. So x, this is defined in this way, the difference, you know it, and this is the ratio, you know it. If you multiply it by 100, this will be the relative percentage error, and here gx is given like 1 plus x by 2, where the starting value is taken as 0.8. Okay, the starting value is taken at the initial guess. This is the initial guess, and the function gx is given like this. Okay, let us come to check this. What happens? Linear convergence. I remove this. I think nth iteration. K is equal to 12. So 1.999. Again, this has come 1.999. means this difference is going to be very, very small. This difference 0.0001. Then the iteration process is stopped. When difference becomes very, very small, 0.0001 means what? This is zero. So difference has become zero. The difference between this and this is zero, means the value has already come. There is no further improved approximated value we are going to have. So this is a constant, and this is convergence is to what? To value 2. 1.999 means what? It is equal to 2. Notice that ratio of successive increments in the last column of table 1.8 are all exactly equal to half, and the convergence of the sequence to x is equal to half is linear. And if you look at this trend is going to be all a linear. This change, this change, this change. If you draw, you will find this change is quite linear. Not a sudden or abrupt or any steep change. We call this sequence exactly linear sequence. This is a linear sequence according to 1, 2, 3. A is equal to like this. This is the sequence. So this is a linear sequence. And this is represented as delta x k plus 1 is equal to this difference CL delta x for all k is greater than. Hence, here CL is half. If you multiply half this difference, you will find this value. So xk is said to converge linearly. The sequence xk, this is the sequence. The sequence xk is said to converge linearly provided the ratio of the increments. This ratio tends to a constant quantity CL. This is a constant quantity CL, where 0 is greater than, less than, CL is less than 1. Now there is also connecting to audio, who is linear convergence theorem. There is one linear convergence theorem. X is equal to dx, so x is equal to a fixed point in the iteration. The first derivative is continuous in the neighborhood of fixed point x, and the first derivative is not equal to 0. And this, if this happens with this one x, the sequence this diverges linearly with this condition, and the sequence converges or diverges slowly if this is not equal to 1. And this kind of condition you have already studied in the nature of the convergence. When converges, when diverges, when converges or diverges slowly. So if S is equal to 0 and S1 is